Hello, ladies and gentlemen. Hello, and welcome back to the Nigerian Azure Community Live Study Sessions. So, this evening we have something very special and very interesting. So, a few weeks ago, we started or just last week actually, we started the Azure Administrator Live Study Series. And while we started that, as the community members just exploded with requests for a DevOps series, and lots of people went, "Can we have DevOps series? Can we have a DevOps fundamental series?" And we just thought we need to respond to what the community are asking for, and that's how we came about this whole DevOps live study sessions. Anyways, we have some of the brightest minds in DevOps, not only in Nigeria or in Africa, but even just around the world. We have some very, very quality speakers that will be walking us through different sections on DevOps. Just some quick information for you on what we have planned. So today we'll have DevOps fundamental training, DevOps fundamentals, which is the basics of DevOps by Ewere Diagboya. And next week, we're going to be having Damilare Ibrahim walk us through DevOps tooling. And after that, we have Introduction to Infrastructure as Code by Raphael Gab Momo. So that's the plan for what we have for you. So, but for now, let's go ahead and bring in our able speaker. Hello, Hewewe, how are you doing today? So, hi there.
Hello, I'm here. Hi.
Awesome. Very good to see you. I've heard a lot about you. I even heard that you wrote a book. I'm not sure. Like,
Well, that's what they said on the news. I think I'm hearing to like you.
that's awesome. So what's the book? Because your name comes up anytime we look up like cloud in Africa, cloud in Nigeria, and I believe that you're actually is it the first AWS hero, which is sort of like the equivalent for those that are not aware because it's an Azure oriented community. That is sort of like the MVP equivalent, right, for AWS.
Yeah, direct equivalent.
Yeah. And since when did you when did you become like an AWS hero and the first in Africa?
Yeah, that was early 2019. Yeah,
Awesome.
sometime early 2019. I got the email, and that was one of my greatest surprise because all the people who got this kind of recognition were all people from North America, Europe, Australia. I've never seen any black man there.
Yeah.
Black man in Africa per se,
Yeah.
So I was like, nah, something has to change, So
Yeah.
I had to really intensify my community work and get to do a lot of stuff around talking about cloud computing, talking about DevOps, getting people more involved, seeing how I could draw people into this beautiful new world that is changing our world and bringing in a new breed of talent, a new breed of ecosystem, a new way of thinking, a new way of doing things that is here to stay and is not leaving anytime soon. So Amazon called, knocked at the door, and I opened.
Awesome. That's amazing. And I tell you, that's sort of like the equivalent that we are trying to drive as a community in the Azure Nigeria group. We have like a lot of like again very very bright and intelligent girls and guys that are currently on the journey to becoming like Microsoft Azure MVP, and that's one of our goals to have even more MVPs in the community. Anyways, the people are ready; they're waiting for you for DevOps fundamental. I'm going to be taking note as we're talking. If you have questions, ladies and gentlemen, put your questions in the chat window, and Ewewe is going to answer that. But for now, Ewewe, feel free to share your screen and just take it away. I'm looking to learn.
All right, all
Yeah.
right. Okay, hi everyone. Just give me a few minutes to get my setup ready.
No problems at all. No problems.
Yeah.
That's true, Rafael. So I can see a few people going, they are hungry for DevOps. So that's true, Rafael. You saw that in the community the last time. So that was a huge, huge request by the community members. And I can see already there's like a bit of cheating going on here. We already have more attendees than we did with our Azure Administrator session. Is that because of you? Are you like a mini celebrity? Is that what's going on? Oh, I'm not sure. Something happened to your mic. I'm not sure. Oh, we're not hearing you for some reason. Hey, hello, Ashish. Thanks very much for joining. We got Ashish from India. So just let me know when your setup is ready, and with the microphone also, and then we'll be good. Mhm. So thanks very much. We got people from different places. We have Jim from Abuja here. Welcome, Jim. Thanks very much for joining. Uh, we have, of course, we've got the Isai himself. We've got Sir Coffee from Ghana. Welcome, Sir Coffee. Yep. Thanks very much. Okay.
All right.
Yep.
Let's do this.
Yep. So there's a button here, so you can just share your screen below there, and then
Yeah.
I'll just take myself out. Yeah.
All right. Okay.
Yeah. There you go. So I'll go away now.
All right. Hello, everyone. My name is Ewere. I've already gotten some beautiful introduction from David already, so I will just move on into the topic of the day. So I tagged this title DevOps Demystified. So the whole idea is to see how we can demystify DevOps. Unfortunately, I'm not a slide person. I wanted to just do the presentation without a slide, but I think it's good we have a slide so that we can take note of stuff and have information that we can always go back to and look at. So my name is Ewere. I'm an infrastructure and SRE engineer. So let's get into it and look at what DevOps means. Okay, so this is a little bit about my biography. Some things are a bit outdated here. I'm a father of two, actually, not one. So I'm a software engineer. I was a software engineer back in 2003. I used to write QBasic on Windows 98. So I'm among those, you can call it old school guys who started doing tech a long time ago. Okay, so and what happened was that a computer came to the house and I started using Microsoft Word. I got bored. I used Microsoft Excel. I got bored. I used Microsoft Access. I got bored. There was nothing else to do. I built databases already as at 2003, 2004. And boom, there was nothing else to do. So the only thing that drew my attention more to using my computer more was, when I was introduced to QBasic, I could discover that, I could build stuff, I could build new things. So that's another backstory, maybe for another day. So I've worked with different programming languages. I've worked with Python, C Sharp, Node.js, PHP, Visual Basic, and a whole lot of languages. I used to work at Terragon Group. That was before, but I'm no longer there at the moment. When I'm not on my console, I love writing a lot on Medium. I have a blog on Medium. I'll be sharing that subsequently. I also talk on YouTube too. I have a vlog on YouTube. So let's head straight to the topic of today. So the question here is, what is DevOps? This is like a huge buzzword right now in the world. It's one of the highest trending topics that people talk about. And one of the things that I have noticed is there's a lot of misconception, there's a lot of misunderstanding, there's a lot of confusion. I guess that's why a lot of people wanted to understand what it is in the community. I can feel that hunger and that confusion. I also got into it out of circumstance. Okay, so but let's even look at what DevOps means. A lot of people have different definitions of what DevOps is or what it means. People will tell you, oh, in this place, this is what DevOps means. In this scenario, this is what DevOps means. But let's even look at how it came about and what it actually means. So what are the things we need to say DevOps is not, first of all? So let's look at what DevOps is not. So first of all, DevOps is not a role. Unfortunately, in the job market, what you notice is that a lot of people will tell you that, oh, we want to employ a DevOps engineer. Okay, what you hear also nowadays is cloud DevOps engineer. DevOps is not a role. It's not an individual person performing a DevOps role, unfortunately. But sorry, the job descriptions you see out there say a DevOps engineer, unfortunately. DevOps is not a separate team. Now, I've worked in organizations where they say this is what we call the DevOps team. These are the group of people that do DevOps, okay? Or this is the person that does DevOps. It's not a team. It's not a team that is separated from the tech team. What you see happening a lot in organizations is that they have a team called the DevOps team. They have a team called the development team. They have the team called the QA team. And, everything is all separated. That is not what DevOps is about. DevOps is not also
Oh, I think just some slight. I think there's
combining dev and ops team. This is the you find exactly things are okay. And when you Google what DevOps is, the first thing you will always at DevOps is a combination of development and operations team. Okay, that's what DevOps is, a combination of development and operations. When you bring them together, it's called DevOps. Unfortunately, we'll be looking at what DevOps is. I just want us to ensure we debunk some things that you must have read, you must have heard about, or in passing people talk about. The next thing here is DevOps is not a tool. Now, this is the one that bust me off the cracks most times when I hear it. They'll tell you when someone knows how to use Jenkins, it tells you, oh, I'm now a DevOps engineer, and goes to LinkedIn and puts it up there. Boom, DevOps engineer, know how to use Jenkins. Please, DevOps is not about the tool. If you know how to use Azure, please, you're not a DevOps engineer. If you know how to use AWS, it doesn't mean that you know DevOps, okay? That is not what DevOps is about. DevOps is not also about automation. I've met people who tell you, oh, once you're a system administrator and you know how to, you know how to write Terraform, you can do, CloudFormation, or you can do ARM, then you're a DevOps engineer. Sorry, that's not what DevOps is about. And then lastly, DevOps is not a one-size-fits-all strategy. Now, what do I mean by that? You see organizations read how maybe Facebook does DevOps, or they read how Uber does DevOps, or the most popular company out there, Netflix. They see how Netflix does it, and they're like, okay, we want to model our DevOps like Netflix style. Okay, let's do it like this, let's do it like that. It doesn't work that way. Okay, we have said a lot of things that DevOps is not. Okay, what is DevOps? Okay, we've told you what DevOps is not. We've mentioned it's not a role. We said it's not a separate team. We said it's not combining dev and ops team, which is one of the things that I know is going to disappoint a lot of people. Okay. We've also said it's not a tool. It's not Jenkins. It's not GitLab. Okay. It's not GitHub. It's not Circle CI. Okay. We've also said DevOps is not automation. So some people say, oh, once you know system administration, just automate the process, just use Ansible to do deployment. You're a DevOps engineer. That's not what DevOps is about. And I also said DevOps is not a one-size-fits-all strategy. You can't borrow the way DevOps is done in Netflix and bring your organization and say you want to do it. Or you can't borrow the way DevOps is done in Uber, okay, or in Bolt and say, okay, I want to borrow that technique and put in my organization. That is not what DevOps is. So what is DevOps? Now, one of the definitions of one of the great guys in terms of the DevOps community called Jez Humble, he said, DevOps is a cross-disciplinary community of practice dedicated to the study of building, evolving, and operating rapidly challenging resilient systems at scale. I know this is a lot for us to digest. Sorry, let's forget about this. What else can DevOps be? Now, DevOps, this is another definition you're going to find in Google. If you Google DevOps, what is DevOps? You'll find this definition. They said DevOps is a culture shift or a movement that encourages great communication and collaboration, aka teamwork, to foster building better quality software more quickly and reliably, with reliability. Okay, this looks more encompassing. Okay, it's something what just said, but I think this breaks down the grammar a little bit more. Okay, so we're looking at some keywords here. Teamwork, okay, which means people are involved. We're looking at another word here called what? Better quality software, which means we're looking at a process where we can build a system that is better than what exists before. Was there something existing before? Oh yes, there was a process existing before. Okay. Now the last thing we're looking at with more reliability. Now I can veer off a little bit here and talk about what we call SRE. So this is where SRE comes into play. Another confusion you always see out there, people are confusing what is DevOps and what is SRE. So let me just quickly debunk it right here. SRE focuses more on reliability of the system. Okay? So there's a YouTube video that explains this very explicitly from Google. You can check it out in Google, SRE versus DevOps. They're going to explain it deeper for you there and tell you the difference between SRE and DevOps. They are not the same. They are very similar, okay, but their roles are pretty much different. But in summary, this is what SRE is talking about. It's talking about reliability of a system, okay? Uptime of a system, making sure a system is always up. Well, I'm not here to talk about SRE, but I just wanted to point that out because that's also another term that flies around that causes a lot of confusion in the tech ecosystem. We have another definition here that says that DevOps is the practice of operations and development engineers practicing together in the entire service life cycle, from design through development to production support. Now, if you look at the last three definitions I just mentioned, there's still something that rings recurrently. The first thing is collaboration. It said development engineers and operations participating together in the entire life cycle, which is very similar to saying collaboration, communication, and teamwork. Okay, we're getting somewhere. From the design to development process, they're talking about process, okay, which is the same thing as fostering building better quality software. Okay, and then the last thing here says to production support, which is exactly the same thing as saying with more reliability. I talked about SRE and I said SRE is focused more on what? Reliability and uptime of the system, which is exactly what this definition said. Production support. If you're an engineer that supports production, you are more or less an SRE or site reliability engineer. So you can see both definitions are aligning and three things standing out, which is what we call people, process, and technology. So DevOps is more about people, process, and technology. Forget about any definition you've heard anywhere. Forget about anything you've heard. When people tell you that, oh, once you know how to use Azure, once you launch a VM, you are now a DevOps engineer. Sorry, you can't be a DevOps engineer because people are involved, there is a process involved, and you infuse technology. There's an article I read one time, and I was supposed to also write some content around it, which is DevOps without tools. Okay, or DevOps without the tech. To tell you more that DevOps is more of a process. DevOps is more of the method, more about. Okay, so it's not just about it's not about AWS. No, it's more about the process of how things are done. Now, before DevOps, what used to exist? What existed before was that, okay, if a developer builds a tool, okay, or builds something for our servers, they just give it to them and they get into the servers. Okay, that's what used to happen. Now, what was the problem with that? The problem with that was that there was no proper communication. There was no process of sending those things the developer has built to whoever needs to get it done. There was a wall, more or less, we'll call it a wall that stands between the developer and the operation system. And if you've watched this movie called Silicon Valley, you're going to see a real life scenario of what no DevOps means. That means, if you look at the developers then, I've forgotten their name, Dinesh and the other guy that was in charge of the infrastructure, they always argue. You see the guy say it's your infrastructure, the other guy says it's your shitty code, the other guy says your infrastructure is your shitty code. That is a no DevOps environment. That means if anything happens, we look for who to blame. We look for who caused the problem, we look for who caused the problem, and we blame the person and we accuse the person. That is not DevOps. DevOps is when people sit down together and say, okay, we want to build a system, okay, and we allocate who does what. Okay, now after we allocate who does what, there needs to be a proper galvanization of our work that we do. There needs to be proper sharing of information across board. There needs to be a process to how we do what we do. Very simple example. If I'm building an application as a developer and we're using Git as version control in our organization, my Git code must always have a README that explains the process of deploying that code. That is a process in place. When the infrastructure guy is setting up a server, okay, where they want to deploy code, he must ensure that there's a monitoring system and there's a feedback loop to the developer on how the system is behaving. That is a process. When there is a downtime in production, there should be a process of how we fix the downtime. What are the steps? Who is the first person to call in to get that stuff done? What are the tools and services that we have locked in across with working with the processes on how to make sure that we ensure high reliability of our system. We ensure that downtimes are always recorded. We ensure that we measure what we call mean time to recover. Okay, those are some metrics of measuring the speed and the efficiency of your DevOps process. All the things I mentioned are more of the DevOps than the Jenkins, than the cloud engineering, than the CI/CD, which are all layers of DevOps. But it is more on the process, it is more on the culture. That is why you cannot just steal a DevOps process from Uber or for Taxify and say that is what you want to do in your organization, because the people are different. The communication is different. The process is different. I mean, take a look at what remote work has done to the world. It has changed the way we see work. It has changed the way we understand work. Gone are those days that you get up on the table and go and talk to the next person and tell him to do what you want to do. Nowadays, you have to send a Slack message, and the person is not there. There's nothing you can do. So it invariably means that the process of work has changed. The method of work has changed. That is exactly what DevOps is preaching. Change the way you see work. Change the way you interact. Change the way you communicate. When there's a downtime, don't point at somebody that it is your job. Please go and fix the downtime. That is not DevOps. That's just old school software development process. It should be a case of, oh, we noticed a downtime. What do we do? How do we collaborate together? Do you think it's an infrastructure problem, or do you think it's a dev problem? Have you checked the logs? Have you checked this? And you collaborate and fix the problem. Because the truth is that in the end, when the system is down, the business suffers. And when the business suffers, revenue is down, okay? Everybody suffers, okay? So DevOps is trying to tell you that, hey, it's a shared responsibility. Everyone is involved in this process, and everyone should put in their mind and heart to make sure applications, services, and whatever we deliver to customers are working appropriately. Now, that is the pillar and that is the foundation of DevOps. The next stage of DevOps is now when we talk about the tools that go with DevOps. So what you see most times is people are more focused on the tools in DevOps than the process of the DevOps, because fortunately and unfortunately, without the process, you can't do DevOps. It's just like the human beings. We all are process beings. When you give birth to a child today, the child doesn't start talking. There is a process of developing how to talk. When you give birth to a child, the child is not going to start walking. There is a process for walking. The child will first of all try to stand. The child will first of all crawl. The child will first of all fall, he stumbles, and then he starts walking. That is exactly what DevOps is talking about. So if you want to do anything, whether you want to set up a server, you want to write a code, there is a process to it. There is a thinking process. There is an architectural process. There is a structural process to it. So the goal here is your focus should be more on the method of how you do it, more than what you are doing. Okay? Because if you pick up a tool today, okay, let's say assume I want to write a Terraform code to set up a 10 VMs in Azure, having an Azure Kubernetes cluster behind it. So all these things are all interconnected. Okay, all these layers of the system are all interconnected. Decide which of them you are going to set up one after the other. It is going to come crashing down. Okay, so no matter how many tools you understand, no matter how many, the method how you do it matters, because if you don't design this flexible, to be scalable, to be reliable, the system is going to come crashing down. So that is why DevOps is more about the people and the process than the technology. Now, all these things we've talked about, how do we implement? So there are three ways of implementing DevOps, okay? We're going back to first principles of DevOps. We have the principle flow, we have the principles of feedback, and then we have the principle of continuous learning. Okay, now I already talked about the principles of flow. Okay, I talked about if you're going to set up a Kubernetes cluster, there are components that make up a cluster. Or if you want to set up the deployment of an application, there are components that make up the application. You need to take note of every single layer of that application. Unfortunately, I might not be able to go into that at the moment because we'll spend so much time here. But in the technical layer of DevOps, we have the infrastructure, we have the deployment, okay? We have the availability, which is monitoring and all that, okay? Each of these steps have their principles, they have their flow, they have the method to how they are done. And it is unique for every single organization. The first place I used to work, when we want to go live with any system, we just go live. Okay, we just get, oh, we want to go live. And we're like, okay, fine. We set up a production server, we just copy what we have and we paste and we're live. Okay, I went to an organization and they're like, want to go live. Go live only happens by 10 p.m., between 10 p.m. and 2 a.m. That's one. Two, there's what we call there's a document in Confluence that shows the step-by-step process of how you are going to deploy. That document needs to be approved by the engineering manager and by the CTO before you perform your deployment. When your deployment fails, there's a rollback plan of how you roll back. Now, these are what we call principles of flow. You can see it is different from organization to organization. So that is why the whole process is unique. The second way is the principles of feedback. I mean, you cannot build a system without feedback. What I mean by feedback, when you deploy, how do you know it's actually deployed and is working? When you set up a system, how do you know that system is working fine? When there's a downtime, how are you going to know if there's a downtime? That's where my book we'll talk about later is coming into. So because my book talks more a lot about monitoring feedback systems and how you can tightly design your system to ensure that you get feedback from different layers of your architecture. Okay. So that's where principle of feedback comes in. And then the third is the principle of continual learning and experimentation. DevOps encourages continuous learning. Now, the fact that you are using a specific tool today, it doesn't mean that is the best tool. I mean, when cloud came on, what we knew was just virtual machines. Now we're talking about serverless. We're talking more about quantum computing. We're talking more about AI. You should be ready to learn and unlearn. Okay. One of the most difficult things I've experienced in my career is people hardly embrace what we call serverless because there is a lot of skepticism, there's a lot of fear, there's a lot of it's more like a black hole. People don't know what's going on inside. The cloud vendor just tells you, don't worry, everything is fine, we'll take care of everything for you. But some people are not confident in that. I mean, that's the case of I'm okay where I am, everything is working fine, just let me be. Okay, so DevOps says that is not the way to go. You should be able to experiment new things. You should be able to continue to learn new ways of doing stuff. You should be able to learn new techniques and new methods of doing stuff. So these are the three ways that DevOps encourages you should follow in practicing DevOps process. So apart from the process, let's talk about the tools. Okay, so the first tool we have here is we're looking at the whole ecosystem of tools, as many tools as we can. And there is a journey, there is a continuous cycle of DevOps. If you look at this diagram very well, a couple of tools have been mentioned here, and a lot of them, I mean, all of them are all open source tools. We have Gradle, we have Git, we have Chef, we have Puppet, we have Ansible, we have Nagios. Now, these are all tools that help you implement DevOps processes in a more user-friendly manner, in a more automated process. The process guides the tool, not the tool guiding the process. Okay, the process guides the tool and not the tool guiding the process. You don't allow yourself to be a tool of a tool. Instead, the individual guides a process that guides the tools. Because I get to see a lot of people who are carried away by tools instead of creating a process around that tool, okay, and using that tool for what it was designed for. Okay, one of the funniest things I see a lot, even if there are a lot of articles out there, where people use Ansible to set up infrastructure. Ansible was not designed for infrastructure setup. The fact that it can do it doesn't make it the right tool. You get to a level where it will choke you eventually. Okay, I know that choke is the latest slang in town. To get to a layer where Ansible for infrastructure automation will choke you. There are tools that are designed for that, and they have specific, unique abilities. That is why they were designed for that. Okay, so these tools are here to help you out. And in the middle of it is the core of the DevOps end-to-end process. The whole process of DevOps starts with the planning of the project, what we are going to do, using techniques such as the agile method, which includes what we call Scrum or the Kanban process. And then we have the code, which is where developers write their code. And the tools we have there, we have Git for version control, Subversion, okay, and Jira too. After the coding and they write the code and all, the code gets built. So there are different build tools here. What you have here is Maven, Gradle, and Ant, but you can call any other thing you want to call, npm, .NET Core, Peep, any other build tool that exists, they all fall under that category. And then you have testing. This is where the QA guys come in: automated testing, manual testing, whatever test, load testing, black box testing, white box testing, whatever test you want to call. Even unit tests can fall into this category too. And then the release, which is the technique of making sure the application gets available into where users can use it. There are other tools there. You have Jenkins, you have Bamboo. There are a lot of tools out there that are out there. You have Azure DevOps at the moment. You have Circle CI, you have Bitbucket pipelines, and then the deployment process, okay, which is the activity of making sure the application is available. So the difference between release and deploy is: release is that you are preparing something to be deployed. You have said this is going to go into production. It goes through some process of testing, validation, and we do what we call a release candidates. We tick what we feel that this can be released to the public, and deployment is the activity of taking that to the public. And then we have operate, which has to do with every other thing that has to be configured during the deployment process. And then lastly, we have monitor. Okay, here I have Nagios, Splunk, Sensu, New Relic. Azure Monitor can also fall into that category of monitoring. But this is just a summary of it. But in real life, this is what you see. Okay, so I can't even count the number of tools that are here. I think there are up to 100 tools right here. But look at the top, and that's where the whole DevOps comes in. The first layer here is collaboration. Collaboration tools. We talked about collaboration tools. Don't forget that when we talked about DevOps, the first thing I talked about is teams working together. So you can see collaboration is not out of play. It is after we have collaborated, we have planned, we have talked together as a team, more or less as a family, okay? That is when we start building the systems, because everybody knows what they are building, okay? The DevOps engineer, in quotes, sets up the infrastructure, builds the pipelines for automated deployment, ensure that in some scenarios, performs a security role, okay? Performs security scans, code scans, and make sure that is ready. The tester is in the center of the part of making sure that the application code meets the standards of the business after the collaboration, okay? And then the deployment process is where the application is deployed using different deployment tools. There's Octopus Deploy, there is Rundeck, there is Gaspatrino, there's so many tools right here. And then you have the run, which is the environment where it is going to run. All right, we're coming to the end now, which is talking about the metrics in DevOps. Unlike any other process that has to do with the end-to-end life cycle of an application, DevOps brings in something new, which is metrics, which is measurement of how far we've gone. So before now, you really cannot measure your application development process. You really can't measure it. You just write and deploy, write code and deploy, write code and deploy. You don't even know if your process is better, if your deployment is shorter, if your anything is making sense. Okay, I think I'll give you a real life example here to drive this home very, very quickly. The first time I did my first pipeline in Jenkins, okay, what happened? So we're using Docker Hub to perform what we call deployment, okay, building Docker images, containers, and all that. Now, what we found out was that a build was taking about 20 minutes or 30 minutes, okay? And whenever the developer finished writing the code and the push, we have to wait for 20 minutes, and we're like this. We're waiting, we're refreshing the page in Docker Hub, we're waiting, So there was a day we had a major issue in production, okay? And I was with this, my great colleague, very nice guy, and we're there, we're sitting there. We couldn't go home. We had to wait. And I'm like, something is wrong here. I mean, do we have to go through Docker Hub? That is me questioning the process. Okay? I'm not questioning Docker Hub as a tool, but I'm just questioning the process of Docker Hub. Do we have to do Docker Hub? Okay? So the thinking here is more of the process, the method, than the tool. Maybe there is another way to use Docker Hub, or maybe there is another tool to use. Okay, what are the options existing? That was when I picked up Jenkins for the first time. I sat down, I read through Jenkins, and I reduced the build time from 30 minutes to 10 seconds. Let me take that again, from 30 minutes to 10 seconds. Now, that alone changed our deployment process. Why? Not because I questioned Docker Hub as a bad tool, because we were using free Docker Hub. Maybe if we have paid, it would have been better. But I questioned the process of must it be Docker Hub? What are the alternatives that exist? And the truth about the tools is that the tool also creates its own process around it. So if we are going to use Jenkins to do a build, it means that the way the build will work is Jenkins pulls the repository and does a build and pushes to Docker Hub. What used to happen is we push to Docker Hub, we push to the Git repository, the repository pushes to Docker Hub does the build and pushes to Docker Hub. So you see that the flow has changed, which is what I talked about when we talked about the principle of flow. The flow has changed, the process has changed. More work will come in. That's the funny thing about DevOps. So that's why you need to focus more on the process, because when we're using Docker Hub to do the build, I didn't have to worry about a virtual machine to run Docker, to run my build. I didn't have to worry about maintaining a virtual machine. I didn't have to worry about how I'm going to scale it. Now I'm doing Jenkins. I have to worry about the virtual machine. I have to secure the virtual machine. I have to obey the virtual machine. I have to obey the Jenkins. I have to make sure that and the machine is always up and running, because over time we started fixing issues with the machine. So you see that when you change the process, it changes everything. It changes the way you do things. It changes the way you see systems. After that procedure, after that encounter, the next month, all our projects were ported into Jenkins. Close to 50, 60 repositories were ported into Jenkins. And we had to disconnect from Docker Hub. We changed the flow, we changed the process, and we added more code to Jenkins that we could never do when we were in Docker Hub. So we were able to measure that, to see that what we call the lead time, okay, was actually shorter, which would lead me to the metrics of DevOps. These are the four major metrics I use to measure your development lifecycle. I won't call it DevOps, I call it development lifecycle, which we call SLDC, okay, software development lifecycle, which is from discussion of what a feature means or what a feature needs to be developed, to giving it to the developer, to when the developer is done writing the code, to when the developer makes it available for what they call the DevOps engineer to deploy, when he makes the build, to when he deploys. That's what we call the software development lifecycle. These four metrics helps you to measure whether you are getting better or you are getting slower or you are just stagnant in a point, which a lot of organizations do not measure. They just continue to work. Now, I told you my story of changing deployment time from 30 minutes to 10 seconds. Imagine how it changed the organization totally. So no one had to go to Docker Hub and start refreshing to wait. Why? Because we changed that process, and it reduced what we call our lead time for changes, which is the first metric I want to talk about here. Lead time for changes has to do with, like I said, the time from when the code is ready to when it is deployed. That's what we call lead time for changes. So the measurement here is how much time does it take to get the application deployed? How much time does it take to change something? If one of our buttons are blue and want to change this to yellow, how much time would that take? Is it going to take 1 hour because our build takes 1 hour and then everybody's like, what's going on? We are building. Business says, why have we not deployed? We are building. We will soon be done. Why have we not? We are building. We will soon be done. I mean, that's crazy. I'm going to add another example here. Now, we got into Docker Hub. That was not the end. And then we did more research and found out what we call micro containers. What are micro containers in Docker? If you are used to Docker, micro containers are more of images that are less than the original Docker image. So when we got into Docker, our Docker images were more or less 1 gigabyte, 2 gigabytes in size. Now, after that research and doing a demonstration of how we could reduce the Docker images, we dropped the Docker images from 1 gigabyte to 200 megabytes to 5 megabytes for applications that are running. Guess what happened? Our build time dropped further because we didn't need to download a 1 gigabyte Ubuntu based operating system. We could use an OS like Alpine, which was 4 megabytes or even 10 megabytes, okay, and just put the binary. So we optimized our Docker files, our builds became faster, our images became more secured. So apart from just speed, what about security? What about efficiency of the system? Okay, so that also improved our lead time. So it reduced the time we made changes to our system. The next is mean time to recover. Mean time to recover talks about how quickly can you recover from a failure. Okay, when there's a downtime in your system, what are the processes, what are the techniques you have to make sure that you're able to recover quickly? And the thing about mean time to recover is it is highly dependent on your monitoring tools and your monitoring services. If you have terrible monitoring tools, terrible monitoring infrastructure, trust me, your mean time to recover is going to be 1 hour or 5 days, because for you to recover a system, you need to understand what has happened. You need to understand what failed. And if your visibility into the system is very poor, your visibility is very low, trust me, you're not going to be able to fix that system. You're just going to be guessing your way all through to to know what has happened. The next thing here is release frequency, which means how often do you deploy? Okay, not can you, it's how often do you deploy? So I'm going to tell you we deploy 10 times in a day. When I'm talking about deploy, I'm talking about releasing to production, because people can deploy to staging 50 times a day. But deploying to production is more scary, because if you break things, it means that your customers will have a downtime and people will hate your product because you are not able to give them 99.99% of time. So how frequently do you release? Okay. And then I can add to that is, do you have a rollback strategy? Maybe something fails. How quickly can you roll back? Okay. It's all part of release frequency. So the more frequent you release, that's a better number. For mean time to recover, the quicker you're able to recover from a downtime, the better you are standing. And then change failure rates is, how often do your changes cause failure in your system? Okay. How often do your changes cause failure in your system? When you make a change, how many downtimes do you get? You need to measure that, because if you measure that, you can know maybe month on month or per deployment. Maybe you deployed today and your downtime was 1 hour because of a deployment. You deployed next week, your downtime was 2 hours, and you don't measure it, you don't record this, you're not going to know how to get better. You're not going to know how to do what we call post-mortems that will help you to know when there's a failure, what should be done when there's that failure. How do we ensure that this does not cause a problem moving forward? All right. Thank you, guys. Do we have any questions? Hello, David, we can't hear you. We can't hear you. Hello? No, I don't think I can hear you. Hello?
Okay, can you hear me now?
Yep, you're back.
Yeah. So I'm not sure what happened. My microphone just decided to no. So that was very awesome. That was what I was saying. I was like, this is super amazing. So thanks very much for that session. So there are some questions that we have in the chat window. So I'll go
Okay.
ahead and ask you some of them.
So can we take like 3 or 4, because I'm not done. I just wanted to talk about
Oh, okay.
some things. Yeah.
That's good.
Just
So,
briefly to round up.
yep. So let's start with the first one.
Okay.
So first one is, let's see. So someone asked the question. I'll put out on the window also. So what are the reliable monitoring tools?
Aha. Mr. Kwemi, you are falling to the trap of tools problem. I wish I could see your face. But you are falling into the tool problem. You are looking at the tool first. If you look at the tool first, you are going to miss it every time. Okay, if you look at the tool first, you're going to miss it every time. Look at the process. What problem are you trying to solve? What are you trying to do? What are you trying to fix? What do you want to see? Because there is even a concept called observability. I talked a little bit about it in my book. And sometimes you don't even need monitoring tools anymore. You need to configure observability into your system. Okay, so it's going to become a debate very soon over time, and people are going to be debating monitoring versus observability. But funny enough, they work hand in hand. But there is a level your system gets to where, most especially when you talk about microservices, when you deal with microservices, you cannot be talking about monitoring at all anymore. You're going to be talking about observability, because you need to see the internal communication workings of the system, not the output. Monitoring talks more about output, CPU metrics, memory metrics. Is the memory going up? Is it going down? Is the hard disk filled up? That's what monitoring is about. But Observability is what is going on inside the system. Which API call is slow? Which method, which class, which variable is causing is a drop in the API call? That's observability. So my answer to your question, unfortunately, is I can't tell you any monitoring tool. So you need to answer the question of what problem you are trying to solve. Okay, and then you can now go into Google and find the tool that would solve that problem or set of problems. One of the organizations I'm working in, I was tempted to tell my team that, okay guys, we're going to be doing CloudWatch for everything. Trust me, this last week I was asking myself the question, can CloudWatch solve all the problems? CloudWatch might not be able to do this for you properly. Might not be able to show you this properly. Before you configure 10 dashboards, this tool will do it faster, you know? So I'm not asking myself that question. Can that solve my problem? It can solve my problem. So if you are always obsessed with the tool, you actually always miss it every time. Because you get to a level, that tool will not be able to do everything you want anymore. You start looking for more tools. That is why, to end it, that's why you see organizations are jumping from one tool to the other. Today they are doing Datadog. Next tomorrow they will tell you Stackify. Next tomorrow they will tell you. People are jumping from two because they are carried away by the good campaigns you see. To add to it, there was a time I was doing a lot of research on databases. What is the best database? Do you know what happened, David? Let me tell you this funny story.
Yeah.
I was comparing Cassandra with MongoDB and MySQL. Do you know I went to Cassandra DB website and they showed me graphs of databases. Cassandra was the highest. I went to MongoDB website. They showed me other DBs with Mongo. All the things I was comparing, Mongo was the highest. I went to MySQL websites. MySQL was the highest, and others were down. What does
Yeah.
that tell you? Everybody is selling their products. They don't care about you. And if you sit down with these marketing guys, they will tell you, don't worry, it will do everything, it will solve all the problems, and you'll just be happy, yay, you pay the money, and 6 months down there, like, this is not giving us value.
Yeah.
You won't blame them because you don't know what you are trying to solve.
Yeah. And to your
So
point
that's,
also, because I
yeah.
just saw another question in the chat window, and guess what the question was about? What
Okay.
tools do you recommend?
You see, everyone is crazy about tools. See, trust me, you will miss it. You are going to miss it every time. See, I have been in a lot of interviews. I have been interviewed several times and I've interviewed people several times. And you know what happens to people a lot? When you tell them, in this organization, we use code pipeline, and the person is like, I know Circle CI, I don't know code pipeline. You're like, what's the difference? For God's sake, it's a CI/CD process. You are building and deploying. There's no difference. What is changing is syntax. That's all. You understand the process, which is the foundation. It is continuous integration and continuous delivery. I don't care what you label it, whether it is Circle CI, Johnson CI, Opayemi CI, Etunde CI. I don't care. It is going to solve the same problem. It's going to build code and it's going to deploy code. There's this CI/CD tool called Body.works. Trust me, it's the best tool in the world. You know why? It has a GUI. If you want to do it, just click on it, click on the language, click on save, click on it, click on it. You understand? But trust me, there's one that will tell you I can never use that tool because it doesn't give me this level of customization. So what tool are you going to use eventually? So don't get carried away with tools anymore, please. Don't ever get carried away with tools. And the problem with that tool is that you get engrossed in that tool and you will not be able to use another tool. Sorry to burst your bubbles. If you move from one organization to the other, the tools are going to be totally different. So if your mind is not open to understand processes instead of tools, you will always hit a block every time and always get disappointed that this company is using GitLab. I know GitHub. This company is using Solano CI. I know Circle CI. You know the funniest thing? There is a clear convergence right now. And you know what the convergence is? 90% of CI/CD tools are written in YAML at the moment. 90% of them. So even easier. So, I mean, that's my answer to your question and the second question. Sorry.
That's awesome. I'll let you carry on. I have other questions, but you
All
wanted to
right.
mention a few things.
All
That
right.
was
So
awesome. Yeah.
I just wanted to round up with a couple of books that I always recommend every time. Okay. I always recommend these books, and these books help me to understand a lot of the things I'm talking about right now. And the first one here is the Phoenix Project. I mean, you can raise your hand in the chat if you've read Phoenix Project. In short, out of these three books, if you don't want to read anyone, just read Phoenix Project. I used to have the audio book, but I don't have it anymore. This is the best book on DevOps. This thing will help you understand DevOps end to end. The brief call we're talking about is to help you understand it. You will see how someone was able to transform an organization using collaboration, not even about tools. Because if you get into this book, you're not going to hear Jenkins, you're not going to hear Circle CI. Sorry, unfortunately. You're going to hear process, you're going to hear technique, you're going to hear how they measure downtime. You're going to see how they were able to bootstrap and get better over time. The next book is Accelerate. This book is a very technical book. Okay, so if your power is not strong in terms of technicality of DevOps and research work, you might not just skip the book. But it helps you see how organizations have performed over time. Those that employed DevOps techniques and those that did not. So it's a pretty good book. Okay, but I think it's a bit advanced because when I read it, I mean, the authors of the book are very good people. You know, you can see Nico Fosbring there, Jess Humboldt, Jim Kim, Martin Fowler, and the rest of them giving a forward. And then the last year we have is the DevOps Handbook. This book is a book that you can always go back and refer to when you want to understand principles of, you can see it's talking about agility, reliability. This book will help you a lot around processes. Like I said, it is more about the process than the tools. So these books will help you with that. I can't live without talking about my own book, unfortunately. So, yeah, so this is my book that was launched 2 weeks ago. That's the link to the book. I talked a lot about monitoring, okay? Don't worry that it looks like it's Amazon that is here, but the first three chapters of the book are talking about monitoring from first principle. What is even monitoring? What are the foundations of monitoring? What is the structure behind monitoring? People talk about monitoring. But what is the idea behind monitoring? Why do you need to monitor? What are the things you need to look out for when you want to monitor a system? Because people just say, oh, let's use Stackify. Okay, configure Stackify. What are we connecting it to? Connect to this, just and then we have a dashboard. Okay. Trust me, a lot of people can interpret monitoring dashboards. If you just look at it and they're like, yes, we can monitor, we know what's going on, we are monitoring. Trust me, when there's a downtime, people do more of guesswork than looking at the dashboard to solve the problem. Okay, but this book will help you understand the pillars of monitoring, the foundation of monitoring. I also highlighted the difference between observability and monitoring, which is something I know is a very controversial topic. You know, people don't even understand what is this thing called observability, but it is a very different concept. But the truth is that just like SRE and DevOps, okay, monitoring rides on observability. So observability is under monitoring because if you want to understand the information from observability, you get it from monitoring. So in the book, I talked about monitoring being the outcome of observability. Let me break that down. If your application is slow, 90% of the time, when there is infrastructure, it's not because the infrastructure is bad, it's because the application has a problem. Okay, so if you do observability, you could see that API call that is taking 1 second, 5 seconds, which is eventually making the application slow. Okay, another thing is I can talk about now. When I talk about a language like Java, we talk about what we call GO, garbage collection, GC, sorry, which is a very memory intensive operation. And for Java developers, if you don't manage that thing very well, it can eat up all the memory of your machine. Now, if you look at your memory monitoring dashboard, you're going to see that your CPU, your memory is going off the roof, 90%, 80%. But the problem is not the server. The problem is the code in the server. So observability helps you see it is this function that is performing recursive calls, or it is this number of variables that were declared that was never used that are occupying unnecessary memory location, or it is this connection resource that you did not close that is consuming resource. That is how you can now solve the problem from the inside out instead of trying to solve the problem from the outside in. Observability helps you solve a problem from the inside out. Monitoring helps solve a problem from the outside in because in monitoring, you see the memory issues. That's when you start checking inside. But in observability, when you can see the issue from the outside, you now know how to solve it. And eventually, your memory issues, your slow application issues will be solved. Thank you very much, guys. That's
Um,
all.
well, that was amazing. That was awesome. Just a quick reminder to everyone. So, the recording of the session will be available on our YouTube channel right after this session. So if you're yet to subscribe, the YouTube channel that you're currently watching us on, click on subscribe immediately, and you'll be able to access our future recordings. Also, the link to Ewere's new book that's in the chat. That's in the chat window already. So just click on the link. So Ewe, you sold your book so much. I want to understand. The passion was so strong. Now I want to understand the difference between monitoring and observability. I really, really want to delve into that. And it seems as if your book is the place to start. So that was awesome. That was amazing. Ladies and gentlemen, if you've been questioning to yourself, will I be attending the rest of this series? You have your answer already, right? So that was amazing. Very much, Owewe. I appreciate that. The community appreciates you, and we'll definitely be looking forward to having you speak for us next time.
All right. Thank you very, very much, David. Thank you very much.
By the way, before I go, someone has a final question. Final question, I promise.
All right. I was going to ask if you have any more questions. Maybe we'll take 2 or 3. I think we have some time.
Yeah. Okay.
3 minutes.
Yeah, that's true. So here's an interesting one.
Okay.
Do I need to be a developer before becoming DevOps engineer?
It's a very difficult question to answer. Sorry, give me a second.
Yeah.
All right. I just wanted to get a light on. Yeah. So this is a very difficult question to answer. 2 years ago, I would say no. Now, I will still say no. But the truth is, you need to understand. Sorry, I'm more of a principles person. Okay, so you don't need to build an application. I think the answer to that question is you don't need to be a developer. Okay, developers build applications, right? They write code to build applications. But the catch here is this: you don't need to build an application to be in the DevOps or whatever DevOps engineer word. Okay. Don't mind me, I hate using that word, but you don't need to be a developer. You just need to understand code. The fact that you understand code doesn't make you a developer. I know someone who has been a sysadmin for 10 years. He understands Java code, but give him to write, he can't build a single application. But he can debug. Okay, he can understand the problem, but he cannot build an application. So there's a difference between understanding code and being a developer. So you actually don't need to be a developer, but you just need to understand code. Because the truth is, along the way, you're going to encounter what they call scripting. You're going to encounter it. It's inevitable, unfortunately. I'm sorry. I used to tell people that it is inevitable. Sorry, it is inevitable. Now, there are also a cadet of people which are coming up at the moment, where you don't need to know anything about code and they are doing well. I will call that a lucky cycle. And those are people that are maybe core network engineers who become cloud engineers, or core security engineers who become cloud security engineers. So those guys, they escape programming trap. Okay, but if you are just coming in, trust me, if you know how to write a simple code, I'm not saying you should build an application. Okay, know how to do mathematics in Python, know how to solve a mathematics in Ruby, know how to do some of those basic stuff, know what a variable is, know what a method is, know what all those things are. You will be a better DevOps engineer than people who don't have any idea about it. So That's my advice.
Yeah, and I'll add to that because, like you said, it's about the process. So even infrastructure people and other aspects of the technology space are applying the DevOps processes to their space also.
Yes. So, yes. Very well. Very well.
Awesome. Okay. That was amazing. Really appreciate it again. Again, everyone, follow the YouTube channel, follow the Meetup group. Thanks very much for joining us, and we'll see you next time. Have a lovely evening.
Thanks, everyone.
Thanks.
Bye.